Okay, lecture 3 covers physical and chemical properties and physical and chemical changes. So you should know the definitions of each of these terms, but the best way to talk about them is just to go right into a problem. Which of the following statements describe physical changes and which describe chemical changes? A chemical change involves a rearrangement of atoms, a change of the compounds. So we should be looking for color changes changes in density, changes in texture, changes that are obviously something at the molecular level has adjusted, it has been rearranged. Physical change, there are no rearrangements of atoms. So we should think about it as best we can on microscopic level. Has anything happened that has altered the basic composition of our compound? So let's take a look here. Some of them are a little tricky, so it's worth going through here. Which of the following statements describe physical changes? Which describe chemical changes? A silver spoon tarnishes. Well, a silver spoon goes from being shiny and have that metallic look. Tarnish is a dull gray look to it, so it takes away the shininess, gives it a different color, so that's a chemical change. You might not know what's going on when it tarnishes. What's happening is sulfides in the air. Sulfur-containing compounds react with the silver, creating silver sulfide, making it tarnish, giving it taking away its luster. So if there's a color change, something that obviously changes it from that nice shiny metal, that is a chemical change. A piece of paper burns. See, burns, chemical change. That's it. We're done. When you're saying burns, you mean it's reacting with oxygen. Almost always. There's a couple of examples where you can burn something in chlorine or some other really reactive gases. But burns means something horrible is happening to this piece of paper. It's no longer going to look like the piece of paper, and we can all picture that. So that's a chemical change, no doubt about it. Table salt is dissolved in water. Okay, so well, table salt, sodium chloride, if you taste it, it tastes salty. Put it into water, what's it taste like? It tastes salty. Means that nothing has happened to the compound. Now the ions have separated and they're dissolved in the water, but those ions are still the same ones that were in the crystal. So nothing has happened to the sodium hasn't changed its structure. The sodium ion hasn't changed from into the sodium metal or anything like that, and the chloride ion hasn't changed into chlorine gas. So there's been no reaction at all. So this is a physical change. A piece of paper is ripped into pieces. Well, except when you rip it, right where there's that rip, you are definitely breaking up a few molecules, the long pieces of long molecules that make up the cellulose. But otherwise, the paper is intact. You don't rip a piece of paper and it turns blue. You know? it stays as is. So obviously, when you just take something and rip it into pieces or separate it into pieces, you're not changing its chemical composition. So this would be a physical change. A piece of iron oxidizes. Oxidizes means, in this case, that it's going to be reacting with oxygen. But when you see oxidizes or burns, it means that there's a chemical reaction. So that's a good thing to look at. But if you think about iron oxidizing, what happens? It turns from a shiny metal to a orange-brown, brittle substance. So it's changed color, it's changed the density that it has, it's become brittle. Definitely a chemical change. An apple rots. Now, it's not as obvious here. There's so much that's going on when an apple rots. There's literally hundreds of thousands of different compounds that make up that apple, and they're all changing. But obviously, if the apple goes from red to brown and just keeps shrinking and changing, getting mottled across its surface, it's something chemical is happening there. An apple is sliced into pieces. Well, the pieces, if you take a bite of an apple or you take a bite of a piece of apple, same thing, so nothing has happened there. As far as chemically, just a physical change. Chlorine reacts with sodium to produce sodium chloride. Again, there's a key word here, reacts. As soon as you see reacts, chemical change, because a chemical change is a reaction. Now, so when you're talking about physical chemical changes, think of in terms of what's happening on the molecular level. Are there rearrangements of the atoms? If there are, it's chemical change. If there's not, physical change. Now, which of the following statements describe, on here, physical properties and which describe chemical properties? Now, a chemical property is something that often you can't test on, well, most of the time you can't test or find out for sure unless you do a chemical reaction. So in finding a chemical property, if you don't know that something has this chemical property, often you have to change the substance to be sure that it's there. So we'll take a look here. A balloon is red in color. Looking at a balloon and finding out that it's red, there's been no change to the balloon. You've done no chemical reaction to find that property. So that's a physical property. Color is a physical property. Lead has a density of 11.34 grams per mil. To find the density, depending on what you're dealing with, if it's a block of lead, you just measure the sides of the block, figure out its volume, put it on a scale, find out its mass. So the density can be found without a chemical process. So this is a physical property as well. So if you can just look at it or work with it without changing what it is, it's going to be a physical property. Sodium reacts violently with water. First you see it reacts here. So when we have sodium sitting around, assuming there's no water in the air, we just had a block of sodium and maybe under oil, and we're just looking at it. So does it react with water? I don't know. The only way to find out that if it reacts with water, if you don't know, is to throw it into water. So this is a chemical property, that it is very reactive with water. 1.0 molar HCl solution is acidic. Acidic is again a property that it's definitely a chemical property, and the only way to find out if HCl solution is acidic, if you had never heard of hydrochloric acid before, if you didn't know, the only way to check is to react it, to find out, react it with something that's a base. Put your finger in there if you wanted to. 1 molar HCl wouldn't immediately dissolve your finger. It'd probably be irritating after a while. So some chemical reaction would have to be done to determine if it's acidic, so that's a chemical property. Potassium bromide crystals are brittle. So if you take a big crystal of potassium bromide and break it and crush it with a hammer, now you've definitely changed its structure on the macroscopic level, but you haven't changed the potassium bromide itself. It's still potassium ion and bromide ion. That hasn't changed, so whether it's brittle or not is a physical property. And hexane is flammable. Again, sometimes I have as an example gasoline. Yeah, well, we all know that gasoline is flammable, but if an space alien came down and you gave him some gasoline, the only way he could determine if it's flammable is to try to light it. Hexane, same thing. Hexane is flammable. If you weren't sure, you put hexane, you take a match, throw it in there, it'd burn really well, and you'd know that it was flammable. So that is, and you're also changing it along the way. So each of these chemical properties, once you've found them, once you've tested for them, generally the compound that you were testing has changed into something else. But for a physical property, make sure everything's on here. For a physical property, all you have to do is either look at it, do some sort of observation that will not change its structure.